Good morning. So today we start something, I'd say completely new, and that we're going to start graphing. So we're going to spend some time graphing for a couple days. Then we're going to look at things called slope and y-intercept that are going to help us to graph a little bit more efficiently, and then we'll come back to graphing. So we're going to be using those graphing notebooks that we got from me, right? So either if you're using a binder and you have some graph paper, that's fine. But if not, we're going to be using using those graphing notebooks, okay? No loose leaf, no regular notebooks. You're not going to be able to make your own graph paper. I gave everyone a graphing notebook for this reason, so make sure we're using that graphing notebook. So let's quickly recap what we did about literal equations. So for number one, if I'm solving for x, I want to isolate x, so I can simply add 8y on both sides, and I get x equals 12 plus 8y. For the second one, there's two things I need to do. I need to isolate my x term by moving my y term by adding its opposite on both sides. So now I've got 2x equals, let's say, 10z minus 24y, or negative 24y plus 10z. I will divide everything by 2. So 10z divided by 2 is 5z, and negative 24y divided by 2 is negative 12y. And for the last one, there's only one thing we have to do, right? I want just x, so I don't want this 15, I don't want this y, I don't want that z. I'm going to divide everything by 15yz. So on my left side, I divide 15, I divide y, I divide z, I'm just left with x. And on the right side, I've got a plus b divided by 15yz. Okay, so let's talk linear equations, okay guys? So we are going to want to get all of this in our notes, okay? It says a linear equation in two variables has the two variables in separate terms with each occurring only to the first power. All right, a lot of jargon, right? What does that mean? Well, it means that we've got x and y. Now, in some cases, we won't have x. We'll have like y equals 3, but that's a lesson for another day. So I've got x and y. And both of them are being raised to the first power, so I don't see any exponent, right? If I have x on its own, that's x to the first power. How do we know if something's nonlinear? Well, if the variables are multiplied together, which really we're not going to see too much of this year. You don't even really see it for several years, actually. But this is something that we're going to see in a few days, right? X to the second power, right? X to the second power is not going to be linear. So let's talk about even more fundamentally, what is a linear equation, right? A linear equation is an equation that will graph a straight line. Now, what do we know about a straight line? Well, a straight line could be vertical or horizontal, but more often it's going to be diagonal, right? It's going to either look like this, or it's going to maybe look something like that, okay? And we'll get into a discussion about the slopes of these lines over the next few days. But if we graph a linear equation, what we're doing is we're plotting the points that make the equation true. Okay, so let's take a look. Let's understand what that means, right? Y equals 2x plus 3. Now, y equals 2x plus 3 has an infinite number of solutions for x and y. So an example, I usually say, all right, somebody give me a possible value. And someone says, well, if x is equal to 10, then y is equal to 2 times 10 plus 3. So y is equal to 20 plus 3, so y is equal to 23. So one ordered pair, right, because ordered pairs are always in the form x comma y, would be that when x is 10, y is equal to 23. And I'm going to say, okay, well, what's another one? Then someone will say, well, let's do an easy one. What happens if x is equal to 0? Well, if x is equal to 0, then 2x is 2 times 0, which is 0, and 0 plus 3 is 3, so y is equal to 3. Then we say, well, what if x is equal to, I don't know, 5? Well, if x is equal to 5, then y is equal to 2 times 5 plus 3. So 2 times 5 is 10, and 10 plus 3 is 13, so 5, 13. And let's pick a negative number. Let's say x is equal to negative 4. Well, if x is negative 4, y is equal to 2 times negative 4 plus 3. So 2 times negative 4 is negative 8, plus 3 is negative 5. So we'd have negative 4, negative 5. Now, what would happen if I took a big graph, obviously it'd have to be pretty big to fit 1023, and I connected all of these points, this point, this point, this point, this point, and the infinite other points, we're going to get a straight line. And that line is going to look something like this. All right, it's going to have 0, 3, it's going to have 5, 13, it's going to have 10, 23, it's going to have negative 4, negative 5. So if we take some random x values and we sub them in for x, and we evaluate, in other words, in this case, we'd multiply them by 2 and then add 3, we get the corresponding y values, and if we plotted those coordinates, we'd get the equation of that line. We get the visual picture of that line. Now, we're not going to want to just pick random values, right? In other words, I'm not going to say, well, when x is 100, y is 203, because that's not going to fit on my graph. So let's take a look at what we should probably do instead. So I've got y equals 3x minus 4. So what I'm going to do is I'm going to make a table, and I'm going to list a bunch of x values. Now the x values that we're going to start with, at least for today, are negative 2, negative 1, 0, 1, and 2. Now the reason we start with those values is they are most likely to fit on our graph. Now some of them won't, right? My graph here is 7 units by 7 units. I would recommend maybe you guys do 10 by 10, make your graphs a little bigger, but that's the graph that I usually start with. So what we're going to do is we're going to substitute these values for x. We're going to find the y values, and then we're going to plot them. So if x is negative 2, I'm going to do 3 times negative 2 minus 4. So 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. I'm going to do the same thing here. 3 times negative 1 minus 4 is negative 3 minus 4 is negative 7. 3 times 0 minus 4 is 0 minus 4, which is negative 4. 3 times 1 minus 4 is 3 minus 4, which is negative 1. And 3 times 2 minus 4 is 6 minus 4, which is 2. So now what am I going to do? Well, I'm going to take my x value, and I'm going to take my y value, and I'm going to make that into an ordered pair. X is negative 2, y is negative 10. X is negative 1, y is negative 7. I've got 0, negative 4. I've got 1, negative 1. I've got 2, 2. Where am I getting those numbers from? Well, I'm taking the x value and the y value, and I'm putting them in a coordinate. Now I'm going to attempt to plot those points. Well, negative 2, negative 10 doesn't fit on my graph. Negative 1, negative 7 is all the way down here. 0, negative 4 is here. Right? 1, negative 1 is going to be here. 2, 2 is going to be here. And what I can do is I can actually use another point. Now this is not something that's necessary, but I'm going to say, well, what if x is equal to 3? Well, then I'm going to have 3 times 3 is 9, minus 4 is 5. And I'm going to do 3, 5. Now, I shouldn't really even have to do that. What you guys should be able to do is we should be able to figure out the pattern, right? From this first point to my next point, I have to go up 3 and then over 1 to the right. And up 3 and over 1 to the right, and I can do that again. So that's going to be my line. And we're going to connect those 3 things that we're going to do, right? We're going to plot our points, okay? Well, after we plot our points. We're going to connect them, and unfortunately, I can't really use a straight edge on here. It gets a little kind of glitchy, but you're going to do this using a ruler, so it's straight. We're going to use arrows, okay? Arrows tell us that this is a line and not a line segment, meaning it will continue indefinitely. I can go after 3, 5, I can go out to 4, 8. I can go out to 5, 11. And the fact that there's arrows here tells me that the line extends infinitely in both directions. And the last thing we do is we label our equation. Y equals 3x minus 4. All right, so again, you plot your points. They should be in a straight line. If they are crooked, if they look like a lightning bolt, a zigzag, you made some sort of mistake, go back and see if you can find the correct points by substituting again. You're going to take out your ruler, you're going to connect the points, you're going to put arrows on the end, you're going to label your equation. All right, let's do another one. Now, why am I doing this? Well, it says f parentheses x. What does that mean? It means f of x. Well, what does that mean? It means function of x. Well, what does that mean? It means y. So at some point, we're going to see f of x. Now, we don't have textbooks this year, so I'm not going to see it there. But f of x just means that we do something to x. In this case, it's we multiply it by negative 2 and add 3. Translation, it's the same thing as y. Okay, so just so we see it, so we're not seeing it at some point later for the first time. All right, so I'm going to put f of x here, but we know that that really means the same as y. And I'm going to start with those same values, -2, -1, 0, 1, and 2. And I'm going to substitute. -2 times -2 is 4, plus 3 is 7. -2 times -1 is 2, plus 3 is 5. -2 times 0 is 0, plus 3 is 3. -2 times 1 is -2, plus 3 is 1. And -2 times 2 is -4, plus 3 is -1. All right, now what do we notice? Well, as we go down our table, as our x values increase, my y value is decreasing by 2. And the reason it decreases by 2 is because of that coefficient, which we will come to know as the slope of the line. But we're going to hold off on that for a few days. All right, so let's graph these points. I'm not going to write out the ordered pair for you. The first ordered pair is -2, 7, which is here. And then I've got -1, 5. And then I've got 0, 3. I've got 1, 1. And I've got 2, -1. Now let's see if I can extend that pattern. So to get from any point I plotted to the next point I plotted, I went down 2 and I went 1 to the right. Why don't I just keep doing that? Okay? Do you have to do this for everyone? No. But it's important to understand that since this line is continuous, since it's infinite, that it will continue in both directions infinitely. So I'm going to take out my ruler, which obviously I'm not using. I'm going to, oh my goodness, guys, that looks horrible. Let me try that again. That's just embarrassing. All right, let's try this again. Let me take my pretend ruler and connect my points. And I'm going to, 1, connect my points. 2, put arrows to show that it is infinite. And 3, label my equation. So f of x, which again is really just a fancy mathematical way of saying y, or function of x, is equal to -2x plus 3. What is going on with this one, right? So for the most part, we're going to get our equations in the form y equals. That is always the way we want them set up. In other words, could I substitute for x here? I could, but it's going to be a big problem each time I do it. So if you get one that is not solved for y, you need to solve it for y, which in this case requires adding 5x to both sides. So really, what's the equation that we're looking for this one? Again, could you sub in the original one? Yeah, it's going to be a pain. It's going to be very annoying. So why don't we just do it this way? Right? Because y minus 5x equals -3 is the same as y equals 5x minus 3. It's just written in a different form. So this is 5x minus 3. So I've got my x values, which again, I'm going to start with these 5, and sometimes I need more, and sometimes some of them won't fit, as we'll see here. So 5 times -2 minus 3 is -10 minus 3 is -13. 5 times -1 minus 3 is -5 minus 3, -8. 5 times 0 minus 3 is -3. 5 times 1 minus 3 is 5 minus 3 is 2. And 5 times 2 minus 3 is 10 minus 3, which is 7. Let's look at my y values. Well, my y values now are increasing by 5. Why are they increasing by 5? My coefficient of x is +5. And again, we will come to know that eventually as slope. Let's see. Well, I can't fit -2, -13, and I really can't even fit -1, -8. If you made a 10-unit grid, you could do it, but I can't. So I'm going to start with 0, -3. Guys, be careful when one of your coordinates has a 0. Okay, a lot of times you guys just kind of guess, and you'll be like, oh, well, there's 0, -3. Well, no, that's -3, 0. So you got to be careful when you've got a 0 as one of your coordinates. All right, so I've got 1, 2, and I've got 2, 7. Well, it turns out that that's all I can fit, right? I can't fit the next value, which is going to be 3, 12, and I couldn't fit -1, -8, or -2, -13, and that's perfectly fine, right? There's really, literally nothing else we can do about it. So I'm going to do my best to connect these points. I'm going to draw my arrows, and I'm going to label my original equation, right? Y minus 5x equals -3. Could I have labeled this one here? Sure, you could have labeled y equals 5x minus 3, but since this is the question that you were asked to graph, that's really what we should be labeling. Okay, guys, let's do one more kind of quickly, and then you can head off for your now try. Right, so this one I'm just going to fill in the values. I'm not going to do the substitution. We've done a lot of these. So if x is negative 2, when I sub it in, I get negative 4 times negative 2 is 8 plus 2 is 10. Negative 4 times negative 1 is 4 plus 2 is 6. 0 plus 2 is 2. Negative 4 plus 2 is negative 2. Negative 8 plus 2 is negative 6. So I'm going to plot only the ones that I can fit. So I can fit negative 1, 6. I can fit 0, 2. I can fit 1, negative 2. And I can fit 2, negative 6 down here. So I'm going to say, okay, let me connect my points. All right, let me draw my arrows, and let me label my original equation somewhere near the line. Okay, ideally I would write it, let me just kind of, just to clarify this, as if I was writing on the line. It's a little hard for me to do kind of on the iPad that I'm drawing it on, but that's kind of the way that I would label it. But anywhere close to it is fine, as long as someone that was scoring your test or looking at your paper can tell what it is. The reason that we have to label is eventually we're going to be doing 2 of these lines together, and we're going to need to know which is which. So there it is, guys. Your now try. So you've got 2 different graphs, and I want you to do them on the same plane. That means on that same grid that you're going to make now, you're going to draw both of these lines. Okay, so let's see how we did. All right, so for the first one, 4 times negative 2 is negative 8, minus 5 is negative 13. 4 times negative 1 is negative 4, minus 5 is negative 9. 0 minus 5 is negative 5. 4 minus 5 is negative 1. 8 minus 5 is 3. So let's see what this one looks like here. Well, I can't fit any of those initial values. I can't fit negative 2, negative 13, or negative 1, negative 9. I can fit 0, 5. I can fit 1, negative 1. I can fit 2, 3. I realize that I have to go up 4 and over 1, so I can do that one more time. Now I'm going to try to do my best to make a nice straight line here. All right, I'm going to use my arrows, and I'm going to label on my line. All right, let me try to do the same thing with my second one. So this should be easy. I'm just multiplying by negative 3. Negative 3 by negative 2 is positive 6. Negative 3 times negative 1 is positive 3, and then 0, and then negative 3, and then negative 6. So negative 2, 6 is up here. Negative 1, 3 is here. I've got the origin. I've got 1, negative 3, and I've got 2, negative 6. So I'm going to connect my points here. I'm going to make my arrows, and I'm going to label my equation. I'm going to label it maybe down here, y equals negative 3x. So that's what it should look like. Okay, guys, we did a lot. So your homework here, I'm going to scratch off 4 just because that lesson was pretty lengthy, so I don't want to have you spend so much time on your homework. So you're going to do numbers 1 through 3 on separate graphs. That means you're going to do number 1 on a graph, number 2 on a graph, number 3 on a graph. Not that you're giving me some mess where I'm going to see all 3 of them together. Not that I'm not trying to make you do extraneous work. It's just a matter of I need to be able to tell where you put your point and if you made a mistake, where it is. And it's sometimes difficult if there's like just these zigzag lines all over the place. The line should all be straight. Okay, if a line is crooked, if it looks like this, well then you made them, or I guess more, it would be more like you're going to have something like, yeah, like that. Then obviously this point is wrong, okay? Now, if it's completely crooked, we have a few things that are wrong. But if it's just like, hey, everything looks okay, and then we've got this point here, and then it goes back up, then you made a mistake. Questions, comments, concerns, as always, guys, upload your work, post a comment on Google Classroom.